Here's a problem that involves the following scenario that has to do with projectile motion or motion in 2 dimensions. Someone hits a tennis ball here, and by the time it leaves the racket, it has a speed of 20 meters per second at 5 degrees above the horizontal. So that's sort of the launch condition of the ball. The person is 2 meters high, and they're 7 meters from a net, which is 1 meter high. So the question asks, firstly, will the ball clear the net? So given these conditions, after this launch happens, the ball starts flying through the air, will it clear the height of the net? There's a lot of ways of working this problem, so I'll just sort of pick one here that seems to work for me, and it'll see where it takes us. So what I want to do is I want to see how long it takes for the ball here to reach 1 meter in vertical height. The reason why I'm doing that is because when the ball reaches 1 meter vertical height, it is at the level of the net. And I can conclude that if it's over here at that time, it does not clear the net, and if it's over here at that time, then it does clear the net. So that's sort of how I'm going to answer the question of does the ball clear the net, just a simple yes-no question. Now the next part of the question wants to know by how far would it clear the net if it does, and we can figure that out when we get there. So what I'll do to figure out how long it takes to reach 1 meter in height above the ground is I'll set up this equation right here. Which is just equation 1, but it's adapted for the scenario that I'm working on here. This is y, that's y naught, this is v0 y delta t, and that's a half a delta t squared. It's just equation 1, but I put in that I want the specific knowledge of when is the ball 1 meter above the ground, given that I started 2 meters above the ground. Here's the v naught y, there's the delta t, and if I plug all this stuff in, I have a quadratic equation in t. I can solve this for delta t. And I'm going to call it delta t1. It's going to be some number. I'll go ahead and let you do that solution here. But when I see the 1, the delta t1, this is the time it takes the ball to go from 2 meters high to 1 meter high, period. So after so many seconds has gone by, one way or the other, the ball is 1 meter high. To answer the question of will it clear the net now I want to see where is it horizontally relative to the launch point to see if it cleared the net. If it's less than 7 meters, it did not clear the net, because that means it made it to the net's height somewhere in this region right back here. It will not clear the net, because it's just going to continue to fall, and it won't clear the net. If the number is greater than 7, then I conclude that it did clear the net, because it's reaching 1 meter in height over here, so it cleared the net. How can you find that distance? Just use this equation right here. So it's going to be 20. This is supposed to be a 20 here. So what is this equation? This is just equation 1 adapted for the x-coordinate. This is x0 plus v0x times delta t. This describes the horizontal position of the ball as a function of that time which we solved for earlier. So you're going to want to compute this number here based on this delta t1, which is this. And again, if you get some number which is greater than 7, it clears the net. If you get some number which is less than 7, it won't. So I'll let you come to that conclusion there. That's sort of how that part of the problem is going to hash out. Now I believe in this problem it actually does clear the net. And so when you calculate this equation here, you're going to want to find out, you will get a number greater than 7 for this, so you can conclude that the ball reaches 1 meter in height somewhere over here. Now the next question asks, well, how high above the net will it clear the net? So I'm going to work this problem this way. What I'd like to do to see how long it takes to clear the net, or pardon me, how high the ball is when it clears the net, so I can see by how far does it clear the net. I'm going to see how long it takes the ball to get 7 meters. I'm sort of going to reverse my logic and see how long it takes the ball to travel 7 meters, given that it was launched this way. So I'll do it this way. I'll say when is x7, given that it started at 0, and given that it has some initial x velocity of 20 times the cosine of 5 degrees times delta t. I'll call that 7. That's the time it takes the ball to travel. That's 7 meters right there. So I can solve this thing for delta t7, and I'll get some number once again. So there you go. This is the amount of time now it takes the ball to travel horizontally 7 meters. So what I'd like to do now is I want to see what vertical height the ball has at that 7 meters. And I can compare that with the net's height to see how high it must have cleared the net. I can do that using my other equation for y here. I can say y is equal to 2 because it starts 2 meters high, plus 20 times the sine of 5 degrees. There's the vertical height. Now I'm not going to put in delta t. I'm going to put in delta t7. In particular, I want to know where is the height of the ball just at the time the ball travels 7 meters across like that. And of course, the equation usually wraps up here with a minus 1/2 g, and it'll be a delta t7 squared like that. So there's delta t7 like that, same number. This will give me the height that the ball has when it's just above the net, when it's at this 7-meter horizontal height, just above it like that. So this is not a quadratic, you're just sort of solving this for y here because you have the information for up there. And so you get some number for y here. And I believe in this case it's something like 2.01 meters. And given that the net here is something like 1 meter high, you can conclude that the ball must clear the net by over a meter. So this is kind of a nice second part of the problem because it uses this time calculation in a different way. By first finding the time it takes to reach 7 meters, we can use that time to link back to say, well, how high was the ball after that much time has gone by? And that'll tell us by how far it clears the net. Nice problem.